Alright, so good afternoon everyone. So my name is Muhammad. I'm from Group 3 and I'm going to be a group reporter for the reporting result of the last experiment, the Clapeyron experiment. So the objective of this experiment is to apply the Clapeyron equation to determine the latent heat of vaporization of water for a certain pressure and temperature. And after that, we have to verify the result of the experiment to the steam table of the thermodynamic textbook. So the Clapeyron equation is basically derived from the efficiency of the Carnot cycle, which is the work divided by the heat across the system, where the work is defined as the change of the pressure and also the volume, and the heat transfer across the system is expressed as the change of the enthalpy from the saturated liquid to the saturated vapor. And then rearranging the equation, we come up with the first equation over here, where the dP/dt is equal to the change of the latent heat of the vaporization of the water divided by the temperature and also the specific heat from the specific volume difference of the liquid phase and the gas phase. And then assume that the vapor phase is an ideal gas and the specific volume of the liquid is very small. We can come up with the equation where the dP/dt is defined as the HFG multiplied by the pressure of the saturation divided by the square of the temperature and the universal gas constant. And the experimental apparatus that we use for the experiment on last time was the 100 milliliter flask, and then hot plate heater, type K thermocouple, analog pressure transducer, mechanical pressure gauge, and then air bleed valve, vacuum control valve, centrifugal pump, water reservoir, and also a computer with data acquisition system. And the experiment that we did before, we used the glass beads inside the thermoplast, since the purpose of putting the glass beads is to increase the surface area and also increase the rate of the condensation from the liquid phase to the vapor phase. So the procedure that we did last time, once the apparatus is set, so the pump was turned on to create a vacuum condition inside the flask, and then the heater place was plugged in and then set to the high settings, and then the thermocouple is placed inside the flask, but to make sure that the thermocouple is submerged inside the water, not to touch the glass beads and also the wall of the flask, because it will create different measurement of the temperature instead of the water. And then the data was recorded when the water starts boiling. As the water starts boiling, the vacuum control line was closed slowly to increase the pressure, and then the air bleed valve was open when the pressure almost reached the atmospheric pressure and the temperature reached around 96 degrees Celsius, and then after that the data recording was stopped. And then once that finished, the heater plate was turned off. So this is the result of the pressure versus temperature based on the experimental data compared to the steam table. So visually, the graphs have same slope and also functions, which is exponential, but the intercept that makes the experimental data a little bit higher than the steam table, probably because of the error that happened during the experiment, which comes from the human error or probably the experimental setup that is different compared to the steam table. And using the Clapeyron equation, we can find the latent heat of the vaporization of water by finding the dP/dt with three procedures. So the first procedure is to finding the local derivative of the pressure, where basically finding the dP/dt is just the pressure difference divided by the temperature difference between one state to the other state. However, it's not convenient to be used, since this causing a lot of error and also high range of error, which needs to be reduced. So based on this result, since this error is not good for our measuring the latent heat of the vaporization, we can start to move to the second procedure, which is find the derivative in a certain range of the temperature. So here I divided into 3 different range of temperature, and then curve it the graph into linear feet. Once we get the dp/dt, we can start to plot the HFG versus the temperature, which we can see the result here. Which since we have 3 different slopes based on the 3 different ranges that I calculated before, and move to the third procedure is doing regression result. Since we know the HFG function is linear from the previous procedure, we just have to find the constant of A and B, and doing the calculation of the regression, we got this type of result. It's producing the linear result of the latent heat of the vaporization of water. So in conclusion, during the process, the error might be happen because of the human error and also probably the experimental setup, and the relation of the HFG and the temperature can be determined by 3 procedures, which is the regression. The last procedure is the best one to get the answer of the relation. Thank you.
Thank you, Mohammed. I have a question for you. Can you discuss how the location of the thermocouple might influence your results?
Okay. Yeah, so as we can see here, the number 3 is the thermocouple, and this one is water. So this position of the thermocouple needs to be placed right submerged in the water, so that the thermocouple will measure exactly the condition of the water instead of the temperature of the flask or the glass beads.
Gotcha. Okay. Thank you. Any other questions?